Our job here is to look at this list of compounds and decide if they are ionic or molecular, and then name them. Ionic will, of course, have a metal and a nonmetal, or a polyatomic ion. Molecular will be composed of nonmetals. So in this first compound, we have Tl and Br. Let's look at where they are in the periodic table. Thallium is a metal. Bromine is a nonmetal. So this is going to be an ionic compound. Therefore, we need to name it according to oxidation state. Now, since thallium is in a region where the oxidation state is not set, and in fact you can have thallium plus 1 or thallium plus 3 compounds, we'll need to specify the oxidation state. So if we go back, the Br is going to be bromide with a -1 charge, since the bromine is in column 7. Don't forget that ide is a good ending for a monoatomic anion. Tl stands for thallium, and we know if there are 3 bromides with the thallium, it must be thallium plus 3 for the charge. So this will be named thallium 3 bromide. And of course, it is an ionic compound. Our next compound has sulfur and fluorine. Again, let's go to the periodic table. We see sulfur, we see fluorine. These are both nonmetals. Therefore, this is a molecular compound. So we will write sulfur for the front, hexa for 6, and then fluoride. Notice we still have the ide ending, even for molecular compounds. Our next compound has 2 bromines and 5 oxygens. I don't think we need to visit the periodic table. I'm pretty sure you know this compound is molecular because bromine and oxygen are nonmetals. We have 2 bromines, so that will be dibromo, and 5 oxygens, so we will use pentoxide. Sometimes we drop the A, so it's not pentaoxide, just pentoxide. This next material, NH4BrO3, appears to be made of all nonmetals. But if you ever see NH4, perhaps you should recall that there is a compound called ammonium, which is NH4+. So it has a polyatomic, so this makes this an ionic compound. So we will start with ammonium. The other piece is BrO3, 1-. So hopefully you remember bromine is in group 7, and this is an oxoanion with 3 oxygens attached to the bromine. This is bromate. Our next compound, barium, with 2 NO3 units, also has polyatomics, not to mention that barium is a metal, so we know to name this according to ionic conventions. Barium is right here in column 2, and you won't find barium as an ion in any other oxidation state besides +2, so we don't have to specify the oxidation state. Anybody working in chemistry realizes the barium in an ionic compound can only be +2, so we will not use any Roman numerals. The other piece of this is nitrate, NO3 1-, and that is a common polyatomic, which you should be working on memorizing. The next material also is ionic because we can see a metal and a polyatomic. Let's go find RH on the periodic table. RH, or rhodium, is a transition metal, so it can have a wide variety of oxidation states. So we're going to have to specify. C2H3O2 has a 1- charge. So with 3 of them, this means the rhodium has to have a +3 charge. So we will name this rhodium, Roman numeral 3 in parentheses, and C2H3O2 with a 1- charge. I hope you are working on learning. That is going to be acetate. Our next compound has phosphorus and hydrogen. Phosphorus is a nonmetal. Hydrogen is also an honorary nonmetal. So we will name this as a molecular compound, phosphorus Try for 3, hydride. My last material has lithium, so I'm sure you realize it is ionic. So we will name this lithium, and then the PO3 is a polyatomic ion. You should know that's PO3 3-, and that is known as phosphite. So in summary, decide if your material is ionic or molecular. Any metals without a predictable oxidation state need Roman numerals. That's why thallium and rhodium have Roman numerals, because they have multiple oxidation states, but barium and lithium do not have Roman numerals.